Hey everyone, and welcome back. We're going to begin working through our machine learning project using scikit-learn. For this project, we'll be using a dataset on passengers who were on board the Titanic. This is a very famous dataset for data science and machine learning, and is very commonly used as an introductory project to use when learning or teaching machine learning. The purpose of this project is to predict whether a passenger survived or not, and then also see what factors affected people's chance of survival. We'll be using a semi-prepared version of this dataset, which I've downloaded from kaggle.com, which is a site that you might remember from earlier on in the course. Let's go ahead and move over to Kaggle and have a quick look at this. Okay, so here I am over on Kaggle. As I mentioned earlier on in the course, Kaggle is not only a place to find datasets, but it also hosts lots of different competitions too. Some of these are hosted by Kaggle, and others are hosted by large companies where the winners will often be paid or offered jobs. One of these competitions is on the Titanic, which we can see here. I've already downloaded the data that we'll need for this, which we can find in either the section 19 folder, or there's also another raw copy within the datasets folder too, just in case you make a mistake and need to revert back to the original file. Inside of the section folder, you'll find the completed notebook file, a PNG file, which contains a description of the different columns in the dataset, as well as two CSV files called test and train. And these will be the two datasets that we'll be using throughout this section. For our first lecture on preparing the data, I'm just going to walk through the existing notebook file, as the majority of our work here is going to be just general data cleaning using pandas, which we're already familiar with from our work over the last few sections. So feel free to either just watch along here for this lecture, or if you like, you can also create your own notebook and type the code out as we go along. But in the next lecture, when we create our machine learning model, we'll be walking through the code from scratch. This lecture is really just to clean and prepare our data. The first thing that we've got here, up at the top, is a quick overview of the goals for this section, along with a description of the different columns. Most of these are pretty straightforward, but the really important one here is the survival column, which indicates whether or not that passenger survived. A 0 means that they didn't, and a 1 means that they did survive. We've got a list of the different tasks that we're going to be working through here, so feel free to pause and have a read through these. With all of that said, let's get started. Starting out, I imported all of our libraries, as well as importing our two datasets, which were train and test. As you might remember from the last lecture, I mentioned that one of the steps involved in the supervised machine learning process is to split our dataset into both a training and test or validation dataset. But sometimes the data you receive may already have been separated. We then just go through some basic exploratory data analysis in order to understand what our data looks like and if there's any errors or null values that we need to deal with. We can see we've got our passenger ID, whether or not they survived, their P class, which is just their ticket class, with a value of 1 being first class, 2 being second class, and 3 third class. Name, sex, and age are all pretty straightforward, but then SIB, SP, is their number of siblings or spouses on board the Titanic, PH is the number of parents or children who were on board. Ticket was their ticket number. Fare is how much they paid. Cabin was just their cabin number. And then finally, embarked is just the port that they embarked from. With C being for Cherbourg, Q for Queenstown, and S being Southampton. Calling info on this, we can already see that we've got some null values in our age, cabin, and embarked columns, which we'll deal with a little bit later on. Finally, let's also just call describe on this to generate some descriptive statistics about each of our numeric columns. And here, I've just gone ahead and made a heat map to visualize our null or missing values. This is a pretty cool trick that you can do with heat maps, because typically you'll just be using heat maps to plot the correlations between different variables. To create this heat map, all we'd have to do is first off call the heat map function, and then for our first argument, which is the data, I provided our data frame, but then with the .isNA method called. If we call this just as is, we'd get a heat map that looks like this, but to disable our color bar gradient as well as the Y tick labels, we could just set both of these arguments to false. And then I just finished it off by setting a color map of magma, which I think looks pretty good. So basically, this is just a heat map which is plotting the Boolean values for our missing data, which comes from our .isNA method. Every white line here just shows us where we have missing data. So the more lines there are, then the more missing data we have for that column. As there's not too many missing data points for our age column, we could probably impute this value with something helpful, such as the mean or median, instead of needing to drop those rows. Our cabin column, on the other hand, has way too many missing rows, so we'll need to deal with these in a different way. But again, we'll deal with this issue when we clean our data in a little while. For now, let's just continue to explore our data. I created two new variables called train numeric and train categorical. Each of these just selects the numeric and categorical columns from our entire dataset respectively. We could, of course, also use the select_dtypes method for this, but as there's not too many columns here, I decided to just select them all manually. I then created a for loop which iterates through each of our numerical columns and then just plots the distribution of each one using a histogram which I created with Seaborn. In terms of our age, young adults look to be our most common age group, with those aged 20 to 30 making up the majority of all passengers. But then we also did have a couple of very young children, as well as some elderly people who were getting on for nearly 80 years old. The most common number of siblings or parents and children was 0, but again we did also have a couple of outliers, as we can see from these next two histograms. Finally, in terms of fare, the average fare by far was definitely towards the low end of our chart, with a little over 300 people having a fare of what looks to be around 20 or 30 pounds. As this count plot shows, more passengers on board the Titanic unfortunately died than those who survived. Around 540 to 550 people died, while only around 340 survived. Here, I decided to break the survival rates down a little further by the class of the passengers. We can see from this that the passenger class did look to have an effect on the chance of survival, with first class passengers having the highest survival rate out of all the groups. This could be due to a couple of reasons, but one is that they were likely to have been closer to the deck and lifeboats. The last plot I made was a heat map to visualize the correlation between each of our numeric variables. Okay, now that we've visually explored our data, it's time to clean up some of the issues that we spotted earlier. A big thing when working with machine learning libraries like scikit-learn or stats models is that they don't work well with missing data. So we're definitely going to have to deal with those missing values that we saw earlier. Something important to remember, which I've mentioned here, is that where possible, we should fill the data instead of just removing it. As the more data we have, the more data our model has to learn from, and vice versa. But in cases where the data we filled would be massively inaccurate, we'd instead be better just dropping it, as poor quality and inaccurate data will nearly always produce worse results than missing data. As we saw before, we had a few missing values in our age column, a lot in our cabin column, and then just 2 in the embarked column. To explore the missing data in our age column a little further, I created a pivot table using a custom aggregate function which I had set as a lambda expression. And this pivot table just showed us that the majority of missing data for this column came from our P class of 3, with 136 of our total 177 missing values coming from this class. You may remember I mentioned before that depending on the number of outliers and skewness of your data, we would be better either using the median or mean to fill our missing values. Median tends to work well for skewed data with a lot of outliers, and mean works well for when the data has a normal distribution. And with this box plot that I created, we can see that this data does have quite a few outliers, so I decided to use the median. Instead of just filling each missing value with the median for the entire column, we could take this a little further and fill each group with the median for its own group. So, for example, we'd fill the P class of 1 with the median for that class, and so on. To do this, I grouped our data together and then called median on it, and then I went through and filled all of the NA values in this column with our newly grouped data. So we now have no more missing data for this column. I hope what I've done there, and also why I did it, has made sense. If you've got any questions about this, then please post them down in the Q&A section below. After this, I just went through and dropped the entire cabin column, as it had a lot of null values and wouldn't have been helpful to our model. And then I also called drop NA to remove the final 2 missing values which we had in our embarked column. It's important here that I dropped the cabin column first, or else our drop NA would have dropped a lot more rows than it did. So now we can confirm that there's no more missing data in our dataset. The final thing that I did with regard to preparing our data was a little bit of feature engineering. Our sex column is currently categorical with male and female. Our machine learning model wouldn't be able to do anything with this, so I created a new isFemale column with values of 0 and 1, which our machine learning model will be able to work with and interpreter. Alternatively, we could also have replaced male and female in our dataset with 1s and 0s too. This code just takes the sex column from our train data frame, creates a new column based on this equal to operator, and then we return it as an integer using the asType method. And the reason for this is that most machine learning models work better with integers than Boolean values. And then to finish it off, I just went through and dropped the other categorical columns that we don't need, which were the sex, embarked, name, and ticket columns. And doing this would just have made our dataset a bit smaller and faster, as well as easier to read for us, as well as converting our fare and age columns to be an integer, as previously these were both floats. Okay, so that's it for the data cleaning and preparation steps that I took for this project. You can find the notebook file for this within the section folder, so if you didn't code out your own notebook file, then you can use this version instead for the next lecture, and that will be completely fine. In the next lecture, we're actually going to create our machine learning model and algorithm, which we'll do together and step by step, explaining all of the key steps and code along the way. I hope you're excited for this. We'll end up making a relatively very accurate and high quality algorithm and model, but a big part of creating a good model is first off getting your data right. So the work that we've done in this lecture is also super important. Alright, thanks everyone. I'll see you all back in the next lecture.